Okay, our first question is going to use Ohm's law to help us solve that. So we know that voltage is equal to current times resistance. So in this case, I have 2 amps of current, and I have 8 ohms of resistance, which gives me 16 volts. Okay. Number 2, a battery does 18 joules of work on 3 coulombs of charge. What voltage does it supply? Well, we know that voltage, the units of voltage are volts, which is the same thing as joules per coulomb. So I have 18 joules, and I have 3 coulombs of charge. So that is 6 joules per coulomb, also known as 6 volts. Okay, number 3. Using the relationship power equals current times voltage, find out how much current is drawn by a 1200 watt hairdryer when it operates on a volt. Then use Ohm's law to find the resistance of the hairdryer. Okay, so P is equal to IV, and they're asking me about how much current is drawn. So I'm going to solve this equation for I. I is equal to P over V, so that's 1200 watts divided by 120 volts, so that is 10 amps of current, or amperes is my units of current. Okay, then use Ohm's law right here to find the resistance of the hairdryer. So resistance, when I solve Ohm's law for R, I get V over I. My voltage is 120 volts. I just found the current, it's 10 amps. So that means the resistance of the hairdryer is 12 ohms, and that is the symbol for ohms, the units. Okay, number 4. The wattage marked on a light bulb is not an inherent property of the bulb, but depends on the amount of voltage to which it is connected, usually 110 or 120 volts. Calculate the current through a 40 watt bulb connected to 120 volts. So I look at what I know. I know the wattage and the voltage, and I'm asked to find the current. So here we go. The wattage is the power, the voltage and the current, so I'll use this equation, and I'm going to solve it for I, for the amount of current. So I is equal to power divided by voltage. So I've got 40 watts, and I have 120 volts. So that looks like 1/3, or 0.33 amps. All right. Number 5, power dissipated in a toaster that has a resistance of 14 ohms plugged into a 120 volt outlet. Okay, so I know that power is equal to current times voltage, but they don't give me the current. They only give me the voltage and the resistance. So I can use Ohm's law. I know that I is equal to V over Ohm's law, so I can rewrite this as V over R for the current times this V, and so that becomes V squared over R. So that is 120 squared over 14, and when I plug that into my calculator, I get 1,028 watts. Okay. Number 6. Calculate the cost of running a 5-watt electric clock continuously in a location where electricity costs 10 cents per kilowatt hour. So I'm using the units here to help me figure out what I have to do. I have to multiply kilowatts times hours. So they tell me the wattage, it's 5 watts. So I have to convert that to kilowatts. So I'm going to multiply by my unit converter. I know every kilowatt is the same as 1,000 watts. So when I do that multiplication, I get 0.005. Okay, so that's the power of my electric clock. Now I need to multiply that by the amount of time that I use it for. Remember, power is a rate of energy use. So if I multiply the rate times the time, I'll get the amount of electricity that I use. Okay, I'm going to run it continuously for a year. So I want to multiply my power times the time, and I'm using it continuously for 1 year. So that is, but that's not the units that I want. A kilowatt year is not what I want. I want kilowatt hours. So I need to change years to hours. So I'm going to multiply that. I know that in 1 year, there's 365 days. And in 1 day, there's 24 hours. Okay, so my years cancel, my day cancels, and I'm be left with kilowatt times hours. So when I multiply with my calculator, 0.005 times 365 times 24, I get 43.8 kilowatt hours. So that's the amount I'm using, and they're asking me for the cost. So for every kilowatt hour I use, it costs 10 cents. So all I have to do is multiply this by 0.1, which is the same as 10 cents. That's $0.1. So that gives me 4.38. $48. And that's my answer.